Hello, I am Dr. Srinivasa, working as an associate professor and head of the Department of Physics in Government First Grade College, Tumkur, belongs to Tumkur University. Today I am going to do the video class on the topic units and measurements. It is a topic in the first unit of basics of mechanics for a paper Mechanics and Properties of Matter, prescribed for the first BSc Physics first sem students. So the session number 1 in this topic, this session number 1. So the first unit name is Basics of Mechanics and the chapter name is Units and Measurements. So what are the learning objectives of this session? So the students should know about the physical quantity, different types of physical quantities, and what is a unit, and different types of units, also a different system of units. The prerequisites of this session are, first of all, the students should know what is physics and the basics of physics and certain applications of the physics. The session outcome of this topic is, from this session, students will be able to understand what is a physical quantity, different types of physical quantities, what is a unit and different types of units, and also the system of units. So the topic name is Units and Measurements. So introduction. So we all know that physics is a science of exact measurements. Understanding of different physical phenomena requires the need to measure relevant physical quantities. That means physics is a science of exact measurements. We should understand the physics subject by the experiments. That means by measuring a different physical quantity. What is measurement? Measurement is a process of comparison of the given physical quantity with the known standard quantity of the same nature. Measurement is the process of comparison of the given physical quantity with the known standard quantity of the same nature. For example, the physical quantity length. Length is a physical quantity. So the length can be measured in terms of millimeter, centimeter, meter, kilometer, etc. In that, so meter is common. That is standard. And millimeter, centimeter, kilometers are the same nature. So what are the physical quantities? Physical quantities are those which can be defined and measured. Without measurement, there can be no advancement in physics. So physics is developed by the measurement in the experimental procedure. Experimental measurements are essential to verify theoretical laws. That means to understand the theoretical laws, the experimental measurements are very needed. We use number of physical quantities in our daily life to describe an event or a phenomena. So what are physical quantities? Once again, anything that can be measured directly or indirectly is called a physical quantity. A quantity which is measurable is called a physical quantity. Physical quantities can be classified into two types: fundamental physical quantities and derived physical quantities. Physical quantities can be divided into two types. They are fundamental physical quantities and derived physical quantities. In the next slide, we are going to know about what are fundamental physical quantities and the derived physical quantities. The physical quantities which are independent of each other and all the other physical quantities can be expressed as the combination of such quantities are called fundamental quantities or base physical quantities. That means the physical quantities which are independent of each other, it cannot depend upon any other physical quantities, are called fundamental physical quantities. Example: length, mass and time, etc. are the physical quantities. I mean fundamental physical quantities. Length, mass and time are the fundamental physical quantities. What are the derived physical quantities? The physical quantities which can be derived or expressed from base or fundamental quantities are called derived quantities. That means the physical quantities which can be derived from the fundamental physical quantities are called derived physical quantities. Examples of the derived physical quantities are speed, velocity, acceleration, force, momentum, torque, energy, pressure, density, thermal conductivity, resistance, etc. etc. That means speed is the derived physical quantities which can be expressed in terms of length and also that means distance and the time, because speed is equal to distance traveled over time taken. So speed is expressed in terms of the fundamental physical quantities as length and time. Similarly, velocity and also acceleration, force, etc. are the derived physical quantities. So what is a unit? So we all know that physics is a science of exact measurement. So measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard called unit. So unit is a standard reference chosen to measure a physical quantity of the same nature. So measurement of any physical quantity involves its comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard called a unit. A standard reference used to measure a physical quantity is called a unit. So measurement of a physical quantity is equal to the product of the numerical value of the physical quantity and size of the unit. If n is the numerical value of the physical quantity and u is the size of the unit, then measure of the physical quantity, that is x, is equal to n into u. That is the product of numerical value of the physical quantity and u, the size of the unit. It follows that the size of the chosen unit is small, then the measured value of the quantity will be large and vice versa. That means this product nu should always constant. If n is small, u should be large, or if u is small, n should be large. Therefore, the measured value of the quantity will be large and vice versa. That is, nu is equal to constant, or the n, the numerical value, is inversely proportional to u, the size of the unit. So n is always inversely proportional to the u. N is numerical value and u is the size of the unit. If n1 is the numerical value of the physical quantity u1 in one system of units and n2 is the numerical value for a unit u2 in the another system of units, then n1 u1 is equal to n2 u2. For example, we know that the MKS system and the CGS system. So 5 meter is the unit of length in MKS system or SS system, and n2 is the numerical value in the CGS system. The unit of length in a CGS system is centimeter, then n1 u1 is equal to n2 e2 is represented by 5 meter is equal to n2 centimeter, or you know that 1 meter is equal to 100 centimeter, so 5 meter is equal to 500 centimeter. That means 5 meter is converted into 500 centimeter, that is equal to N2 centimeter. So centimeter will cancel each other, then we will get N2 is equal to 500. So the relation between the system of units can be defined or obtained using this relation N1U1 is equal to N2 N2. So here N1 is 5 and U1 is meter, that is the size of the unit, and N2 is the numerical value and centimeter is the size of the unit in that system. So N1U1 is equal to N2 U2 always. Types of units. Similar to the types of the physical quantities, there is also types of units. There are mainly two types of units, the fundamental units and the derived units. What are the fundamental units? The units of the fundamental or base quantities are called fundamental or base units. We already know that the fundamental physical quantities are those which can be independent of each other. Similarly, the units of the fundamental physical quantities are called fundamental units, which are independent of each other, does not depend upon any other units. Example, meter, kilogram and second. So meter is the unit of length, that is fundamental physical quantity, length, and similarly kilogram is the fundamental unit of a fundamental physical quantity, mass, and second is the fundamental unit of the fundamental physical quantity, time, etc. Next, derived units. You already know that what are derived physical quantities. The quantity which can be derived from the fundamental physical quantities are called derived physical quantities. Similarly, the derived units are the units which are derived from the fundamental units, and also they are the derived units of the derived physical quantities. The units of the derived quantities which can be expressed from the base or fundamental quantities are called derived units. Example, meter per second. So meter per second is the unit of a derived physical quantity, that is speed or velocity. Similarly, kg per meter cube is the derived unit, which is the unit of the derived physical quantity, density, etc. etc. System of units. Next we will discuss different types of system of units. What are the system of units? A complete set of both fundamental and derived units is known as the system of units. A complete set of both fundamental and derived units is known as the system of units. In most system of units, length, mass and time are considered to be fundamental quantities, and their units are called fundamental units. So length, mass and time are called fundamental physical quantities and their units are called fundamental units. The following are some of the system of units which are commonly used. So then what are the various system of units? In earlier time, various system of units like CGS, FPS and FK system of units were used for the measurement of a physical quantities. They were named so from the fundamental units in the respective system as given below. So in various system of units, there are 4 different system of units. In the earlier stage, the scientists was used 3 system of units. They were CGS system, FPS system and MK system. In mechanics, length, mass and time are the 3 fundamental quantities. For the units of these 3 basic or fundamental quantities, following systems have been used. The first one is CGS system. This CGS system of units was set up in France. Therefore, CGS system of units is also called French system. In this system, centimeter, gram and second are the fundamental units of length, mass and time respectively. So, Therefore, they are called CGS system because centimeter, gram and second are the fundamental units of length, mass and time. It is a metric system of units. What is metric system of units? It uses the powers of 10 for conversions between the different system of units. Second one, FPS system. In this system, foot, pound and second are the fundamental units of length, mass and time respectively. This FPS system is also called British system of units because this system of units was set up in Britain. It is not a metric system of units. CGS system is a metric system of units, but FPS system of units is not a metric system of units. According to FPS system, foot, pound and second are the fundamental units of length, mass and time. So here F, P and S represents foot, pound and second. The third system of units is called MKS system. So this system of units was also set up in France. So CGS system is also set up in France. MKS system of units was also set up in France. In this system, meter, kilogram and second are the fundamental units of the physical quantities length, mass and time. So M represents meter, K represents kilogram and S represents second for MKS system for the fundamental physical quantities length, mass and time. It is also a metric system of units. It is also metric system of units. In contrast to CGS and FPS system of units, the MK system of units is a coherent system of units in mechanics. What is coherent system of units? A system of unit is said to be coherent if all the derived units can be obtained by multiplying or dividing its fundamental units. A system of units is said to be coherent if all the derived units can be obtained by multiplying or dividing its fundamental units such that no numerical factors are introduced. Therefore, the MK system of units was also set up in France in addition to CGS system. So, system of units were given in the table. FPS, CGS and MKS. According to FPS, foot, pound, second are the fundamental units of length, mass and time. According to CGS system, centimeter, gram and second are the fundamental units of length, mass and time. According to MK system, meter, kilogram and second are the fundamental units of length, mass and time. And the dimensions are length, L, M and T. The fourth system of units and the important system of units now we are used is called a SI system, that is system of international units or international system of units. Why international system of units was constituted or given? Prior to SI system, various measurement systems are used like FPS, CGS and MKS. So they are existent before the SI system. So these system of units leading some confusion and difficulties in communication and trade. So these system of units are existed leading to confusion and difficulties in communication and trade because different countries were used different system of units. So it is confusion and there are difficulties in communication and also while trading. The international system of units, that is also called SI system, came into existence to standardize measurements across different countries and fields, promoting clarity, consistency and facilitating international collaboration in science and trade. So these are the important points to construct the fourth important system of units. SI units are used universally in technical and scientific research to avoid confusion with the units, as it is a unit of an international system of measurements. Therefore, throughout the world, so we are using the same system of units, that is SI system of units, to avoid the confusion. It helps to understand the measurements in one set of unit systems in the entire world. It helps to understand the measurements in one set of unit system in the entire world. By having a standard unit system, so the SI unit is very much important. It was found that all the physical quantities cannot be expressed in terms of length, mass and time. MK system was adapted in 1935, which consists of only units of length, mass and time. So this MK system is used to express the derived units of mechanics only. These units are not sufficient to express the derived units or physical quantities which are come across the different branches of the physics. So to express all physical quantities which are come across different branches of physics, at General Conference on Weights and Measures held in 1960 introduced a new and logical system of units called SI system. This is the system of units which is at present accepted internationally to express all physical quantities which are come across different branches of physics. At General Conference on Weights and Measures held in 1960 introduced a new and logical system of units called SI system. This is the system of units which is at present accepted internationally. SI system uses metric system. You already know that what is metric system. The metric system is one which can be expressed in terms of powers of 10, and therefore conversions within the system are quite simple and convenient. The SI system has identified 7 fundamental quantities and 2 supplementary quantities. So in addition to 3 fundamental units in SI system, there were introduced 7 basic units and 2 supplementary units. So the 7 fundamental physical quantities and their units and 2 supplementary physical quantities and their units are given in this table. The 7 basic units and the physical quantities are length, mass, time, electric current, temperature, light intensity, amount of substance. These are the 7 basic physical quantities and their symbols and their units, fundamental or base units, and the 2 supplementary units, they are plane angle and the solid angle. So the 7 basic units: length, the meter is the unit of that length, and kilogram is the unit of mass, and m is the symbol, and kg is the symbol of the kilogram. Time is represented by capital T and its unit is second and their symbol is S. For electric current, ampere is the SI unit represented by the symbol A. For temperature, Kelvin is the SI unit represented by K. So intensity is represented by candela and the symbol is Ct. The SI unit of amount of substance is mole, represented by MOL as the symbol. And the 2 supplementary physical quantities are plane angle and the solid angle, and their symbol is d theta and d omega, and the unit of plane angle is radian and represented by RAD. The unit of solid angle is steradian represented by SR. So what are the characteristics of the standard units? A unit selected for measuring a physical quantity must fulfill the following requirements. Then what are the requirements? First one, it should be well defined. And the second one, it should be of suitable size. It should not be neither too large nor too small in comparison to the quantity to be measured. It should be of suitable size. It should be well defined. And the third one, it should be reproducible at all places. It should be reproducible in any place. So it should not change from place to place or time to time. The unit should not change from place to place, whether it may be India or France or Germany, America. The unit is same. The unit of length is meter in India. It is same in America, etc. In Germany, Japan. The unit of time is second. All over the world, the unit of time should be a second. Like that, it should not change from place to place or time to time. It should not change with the physical conditions such as temperature, pressure, etc. The unit should not change for any physical quantity. It should be easily accessible. The unit should be easily accessible. It should not be difficult to access the unit. So these are the characteristics of the standard units. Then what are the rules or conventions for writing the SI units? How we should write the unit or SI units? While using the SI units, the following are the rules and conventions for writing the SI units and their symbols. What are the first rule? The full names of units, even if they are named after scientists, should be written in small letters. If the unit name is name of the unit, like Newton is the unit of force, the word, the first letter should be small letter. It should not be capital letter. Newton is the unit of force. It should be write with a small letter, not with a big letter. Similarly, watt. Watt is the name of the scientist. It is also unit of power. So, for watt, small w should be written, etc. But the second condition is that the symbols of the units named after the scientist. Here the full names. Here the symbols. We are writing symbols of the units. The symbols of the units named after the scientist should be written by a capital letter. For example, J for joules. If it is a word, small letters. If it is a symbol, it should be capital letter for a unit named after the scientist. And N for Newton, W for watt, etc. Rest of them are in lowercase letters. If it is a name of unit, the symbol should be capital letter. If it is not a name of the unit, it should be lowercase letter. Example, second is written as small s, not capital S. Second is written as S. Meter is small m, like that. Small letters are used as symbols for units, not derived from the proper name, noun. Small letters are used as symbols for units, not derived from a proper noun. For example, m for meter, meter per second for velocity, etc. Fourth point, plurals should not be used while writing the symbol of a unit or its full form. Plurals should not be used while writing the symbol of a unit or its full form. Example, meter, meter apostrophe s should not be used. Simply meter. Seconds, s apostrophe s should not be used. When temperature is expressed in Kelvin, the degree sign is omitted. If the temperature is measured in Kelvin, that is SI system, it should not be used as degree Kelvin. If it is 273 Kelvin, not as 273 degree Kelvin. Degree, this degree should not be used. But if it is measured in degree Celsius or degree centigrade, it should be written as 273 degree Celsius or centigrade. But for a Kelvin, it should be 273 Kelvin, and this degree should be omitted. The symbols of units do not have plural form. The symbols of units do not have plural form. That is already have told you that 70 meter. 70 itself a plural. 70 meters should not be written. 70 meters. Or 10 Newton, not 10 Newtons. The last one is punctuation marks are not written after the unit. Punctuation marks are not written after the unit. So for example, 1 liter is equal to 100 cc. Actually 1000 cc. Okay, not 100 c dot or full stop cc. These punctuation signs should not be used. So I have used the reference books to do this video class. They are Units of Measurements by S.V. Gupta, Units of Physical Quantities and Their Dimensions by L.A. Sena, Concepts of Physics by H.C. Verma, Fundamental of Physics by Pradeep Publication, etc. etc. So thank you for your patience and thank you for watching my video. Once again I thank you.